The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the new Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hot spots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out. Now, at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has two parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot. Ow! Even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore. But when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangaea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they called that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangaea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangaea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novo-Pangea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novo-Pangea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long, and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas Fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific. And 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the 5th largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the 5th largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground, but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of 3 main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have had been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? Alright, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon. Summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, There's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these two being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger. You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder, and suddenly, the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious, life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So, what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken-down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and… whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the Earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled, but all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city.
Doctor, I can't understand what's going on. I feel dizzy and, how do I say it? I'm tilting. It didn't happen overnight. Like, I didn't wake up and couldn't stand straight. No, one day, I felt that my axis had shifted by 1 inch. Another day, it was 2 inches. And once, you won't believe it, it was 31.5 inches. That's alarming. What if I accidentally turned upside down and all my inhabitants fall off my surface? Ah, dear Earth. We ran some tests and are ready to explain an unfortunate combination of factors that has affected your axis. The last one will perhaps be the most unexpected and upsetting. It all started back in March 2011, when a devastating magnitude 9 earthquake struck off the coast of Japan. It was so powerful that not only did it shift Earth's axis, but it also shortened the length of the day. This earthquake displaced our planet's axis by approximately 6.5 inches and may have moved Japan's main island by about 8 feet. Like other similarly massive earthquakes, it also altered Earth's rotation speed. To make it easier, let's compare it to a spinning ice skater. When a skater pulls their arms close to their body, they spin faster by concentrating their mass near the axis of rotation. Something similar happens during the most powerful earthquakes. They shift Earth's mass closer to its rotational axis, causing it to spin faster and shortening the day length. The calculations showed that the Japanese earthquake sped up Earth's rotation by about 1.8 microseconds, which is about 1.8 millionths of a second. Not a big deal, but at the end of the day, every nanosecond counts. For comparison, the infamous Indonesian earthquake shortened the length of a day by 2.68 microseconds. It struck on December 26, 2004, at 0:58 UTC. The epicenter lay off the western coast of northern Sumatra, Indonesia. This powerful undersea earthquake triggered devastating tsunamis that swept across the Indian Ocean, causing widespread destruction and immense loss of life in countries like Indonesia, Sri Lanka, India, and Thailand. Even coastal areas as far as East Africa had severe damage. The Earth's magnitude, initially recorded at 9.0 on the Richter scale, was later adjusted to between 9.1 and 9.3, making it the most powerful earthquake ever recorded in Asia. The faulting, that's when Earth's crust completely breaks and its parts slide past each other, lasted between 500 and 600 seconds, and it was the longest duration ever observed. The immense force of the quake caused the entire planet to vibrate by at least half an inch and triggered other earthquakes as far away as Alaska. All that immense energy the earthquake released caused subtle but quite measurable changes to Earth. The shift in mass slightly changed the planet's rotation, shortening the day. It also caused a small wobble in Earth's axis from 1 to 2.4 inches toward 145° east longitude. So, when it comes to changes in Earth's rotation speed and axis, it's all about the redistribution of mass. This can happen naturally through disasters, but human activities can also trigger it. Take the Three Gorges Dam, for instance. This massive structure across the Yangtze River in China's Hubei province may seem to be an engineering triumph, but it's pretty ambiguous. Finished in 2012 after nearly 20 years, this massive dam is 7,660 feet long and 607 feet high. And yes, it is so big that it can affect the way our planet spins. Its reservoir is capable of holding 9.5 cubic miles of water, has enough mass to slightly alter the Earth's rotational inertia, slightly slowing the planet's rotation. According to NASA, the Three Gorges Dam reservoir could shift Earth's pole position by almost 1 inch and increase the length of a day by 0.06 microseconds. Dams aren't the only worry. If polar ice melts, water rushes into the oceans, hiking up sea levels, especially near the equator. This mass shift slows Earth's spin way more than dams do. You won't feel it day to day, but it can affect ultra-precise equipment, such as atomic clocks. To fix this, scientists suggested a negative leap second, making a minute 59 seconds, to balance Earth's spin changes. Okay, so you're thinking you've got nothing to do with all those tilts. You don't build dams, right? Bad news. If you take regular showers, you're part of it too. Every time you turn on the tap, you're affecting Earth's tilt just a tiny bit. Thing is, our planet is always shifting and adapting, so even small actions like using water can influence its orientation. Over the past 2 decades, groundwater pumping has caused the Earth's tilt to shift by 31.5 inches. This water redistribution is equal to about 0.24 inches of sea level rise. It turns out that among climate-related causes, groundwater redistribution has the largest impact on the drift of Earth's rotational pull. But what is groundwater? It's the water stored beneath the Earth's surface, filling the spaces in soil, sand, and rock. It comes from rain and other precipitation that seeps into the ground, collecting in underground reservoirs, aquifers. Unlike rivers and lakes, groundwater stays below the surface, acting like a natural water reserve. Thanks to it, we have a steady supply even during dry periods. Many people, especially in rural areas, rely on groundwater as their main source of drinking water. Farmers use it to irrigate crops, while industries depend on it for manufacturing and cooling systems. It sounds pretty harmless, doesn't it? How can something so useful cause our planet to shift? Well, a study covering data from 1993 to 2010 revealed that we've pumped about 2,150 gigatons of groundwater in that time. And this large-scale water removal has shifted the Earth's tilt and rotation. After we use groundwater, much of it eventually flows into the oceans, contributing to rising sea levels. In areas like Western North America and Northwestern India, people use a lot of groundwater, and it may have a connection to these shifts. Yikes, let's face it. All these findings are rather disturbing. But you know, understanding the impact of groundwater use is already a huge step in the right direction. Hey, I'm not done yet. This tilting issue isn't just about stuff happening on Earth. We also need to look at space. We've talked a lot about water, right? Well, you know that the moon has a big role in that. Its gravity is super important for forming tides and all that. So one more thing that affects our planet a lot is the gradual movement of the moon away from Earth. These two bodies interact gravitationally, which makes Earth's rotation slow over time. even though significant events like earthquakes occasionally speed it up temporarily. How did we figure it out? Glad you asked. Once, someone paid attention to ancient corals. After analyzing them, scientists realized that Earth had once rotated much faster. The thing is, corals grow by laying down thin layers of calcium carbonate. They do it daily, and variations reflect seasonal changes. By counting these layers, scientists have calculated the number of days in a year millions of years ago. They found that Earth had about 420 days per year 444 to 419 million years ago. But over time, the Moon's influence had caused Earth's rotation to slow. And now we only have 365 days in a year. I feel robbed, you know? At the moment, the Moon is moving 1.5 inches away from Earth each year. That's about the same speed at which your fingernails grow. Astronomers have figured it out with the help of special mirrors placed on the Moon during the Apollo missions. For over 50 years, researchers have been sending laser beams to these mirrors and measuring the time it took for the light to bounce back. In any case, dear Earth, at the moment, your condition isn't critical. As for your inhabitants, they won't fall off your surface. All thanks to your gravity, pulling them toward your center. Just don't switch it off, and everything's going to be fine. At this very moment, scientists are getting ready to explore the Earth's deepest layers, where temperatures are insanely high and the pressure is crushing. It might sound like a plot from Journey to the Center of the Earth, but it's for real. By 2026, the Krafla Magma Testbed project plans to drill into an active volcano in Iceland. Their goal is to search for magma. Yep, that boiling molten rock that we often associate with destruction. It is a high-risk mission and a huge technical challenge, but the payoff can transform our future. This isn't our first attempt to journey to the center of the Earth. Back in 1959, Hawaii witnessed a breathtaking spectacle as red-hot lava violently erupted from 400-foot Kilauea Iki crater. Over the next 5 weeks, lava fountains erupted in 17 major bursts, with the tallest reaching a record 1,900 feet. This spectacular and terrifying event left behind a glowing lava lake in the crater. A few months after the eruption, the lava began cooling and forming crusts. That was a perfect chance for scientists to drill into that lake, see what was going on beneath it, and collect data about the magma reservoir. Over the next 2 decades, they kept coming back, digging a little deeper each time. By 1979, they managed to get 173 feet down. Up to that point, it was the closest we had ever come to an actual magma chamber. And by that, I mean the underground pool where magma sits before eventually rising to the surface and causing a volcanic eruption. Decades later, the dream of reaching magma finally became a reality. We are now in Iceland in the year 2009. The Iceland Deep Drilling Project has just kicked off. Their goal is to transform the Earth's inner heat into clean energy for everyday needs, such as heating homes and supplying hot water for baths. You see, using heat from the Earth's interior to make energy isn't new, but it usually comes from hot water underground, not directly from a freaking scorching magma chamber. That's why the Iceland Deep Drilling Project was such a big deal. Magma could be a clean, renewable power source. And since it's hotter than the geothermal energy we normally use, it could generate a lot more power. Iceland is a natural choice for this kind of project. Known as the land of fire and ice, this country is home to some of the most active volcanoes on the planet. One of the most popular ones is Krafla, a volcanic caldera of about 6 miles in diameter, located north of the island. So, the initial plan of the Iceland Deep Drilling Project was to go there and excavate 13,000 feet deep. But something unexpected happened. When they were only 6,900 feet down, the drill hit magma. Wow! On one hand, it was exciting, because, well, we finally found it. And just like that, Krafla became the first place in the world where we know exactly where magma is. But on the other hand, their equipment wasn't prepared or built for it, and the molten rock basically corroded their infrastructure, bringing the project to an end. Instead of being a failure, this accidental discovery gave us a ton of valuable data. We realized that, with the right equipment, drilling in such extreme heat is definitely possible. Scientists found that these underground molten pools can in fact produce a significant amount of geothermal energy. And most importantly, we learned exactly where the magma was. That brings us to the current Krafla Magma Testbed project. This scientific program aims to create the world's first magma center. The idea is to set up a base where scientists can safely work with magma and have all the necessary infrastructure to run experiments on volcanic risks and geothermal energy. So that's like the basic idea. But their real plan is to return to Krafla, drill back into it, and create a gateway to the magma chamber. The goal is to understand its potential for generating energy, study its properties, and see if we can use it safely and efficiently. If they pull this off, it could provide a nearly endless source of geothermal energy for Iceland's homes and buildings. Even though magma is incredibly hot, reaching over 2,000 degrees Fahrenheit, experts say it is safe to take energy from it and believe the process won't trigger another volcanic eruption in the country. They're so sure about this, partly thanks to the Iceland Deep Drilling Project. But this whole process isn't like drilling for oil or gas. It's way more challenging and risky. Magma is not just extremely hot, it's molten rock, which can wreck equipment and pose serious safety issues. Right now, the Krafla Magma Testbed project is in its early stages. Scientists and engineers are working hard to develop the tech needed to drill into magma safely. They're testing new drilling techniques, creating heat-resistant materials, and running simulations to figure out what happens when you actually drill into a magma chamber. They hope that by 2026 they will be ready for the next step, which means going back to Krafla and drilling all the way down towards the magma chamber. It might take 2 months to reach it. Their plan is to drill a single hole that will go right into the magma body and hopefully keep the equipment running there for many years. If they succeed, scientists also plan to add special sensors down there to measure and monitor pressure. This could help predict eruptions better and prevent disasters, like what happened with Mount St. Helens in the United States. In 1980, this volcano erupted, causing massive destruction and claiming over 50 lives. The eruption was so intense that it completely blacked out sunlight in Spokane, Washington, which is about 250 miles away. While that sounds terrifying, it's nothing compared to a super eruption, like the one that happened over 70,000 years ago at Toba volcano in Indonesia. This disaster was about 1,000 times more powerful than Mount St. Helens. Toba is just one of the 20 supervolcanoes on Earth. A supervolcano is what people call a volcano that can produce an eruption of magnitude 8. These eruptions, known as super eruptions, are the largest and most explosive ones. They could have global consequences by affecting the climate and causing widespread destruction. For example, if Yellowstone had a super eruption today, the surrounding states of Wyoming, Idaho, and Montana would be directly affected. They could be hit by hot avalanches of volcanic ash, gases, and rocks that might reach temperatures of up to 932 degrees Fahrenheit and speeds of over 180 miles per hour. This nightmarish scenario is a real possibility, but predicting when it might happen is almost impossible. Volcanoes don't follow a precise schedule, so it is hard to predict when a supervolcano will erupt next. That is also why the Krafla Magma Testbed is so crucial. By examining a volcano's activity from within, scientists could potentially predict eruptions with much more accuracy. As you might have guessed, drilling into magma is definitely uncharted territory, but the potential benefits are huge. Besides providing a clean energy source and making people who live near volcanoes feel safer, this project might also help us learn more about what is beyond Earth. Yep, it could lead us to breakthroughs in space exploration, helping us understand how other rocky planets and moons formed their crust, just like Jupiter's moon Io, which is the most volcanically active world in our solar system. In the end, the Krafla Magma Testbed project is more than just an experiment. It is a bold vision for the future of energy. It's about pushing the boundaries of science and engineering, taking risks, and dreaming big. So we should definitely keep an eye on Krafla, because this adventure into the fiery depths of our planet could end up changing our future. You rub your eyes, trying to make sense of everything. Perfect circular holes in the bottom of the ocean floor off the coast of Big Sur in California. You have no idea how this happened, even though you're a marine biologist who's been practicing it for years. You go through some of the old records and find out that these holes have been around since the 90s. In 1999, a ship-mounted sonar conducted a survey and found 5,200 of these pockmarks, or large holes over 500 square miles, on the ocean floor. They look like moon craters underwater. You contact your team and get the robot ready to go down and explore the scene and bring back a few samples. You and the team drive to the coast and hop on the boat. You're sitting inside controlling the robot with a joystick. Your teammate sets the robot in the water and drives it down. Everything seems normal near the surface, but as the robot goes lower, the pockmarks start appearing. A bunch of boats swift past you, making you lose your balance and focus. The robot turns on the flashlight so you can see better. But as it goes lower, the resolution is less crisp. It almost reaches the bottom, and the holes are smooth and nearly perfect circular shapes. Some of these holes that were visible in the sonar reading measure more than 30 feet across and 15 feet deep. You show the rest of your teammates the images, and they're shocked. The robot continues swimming, but there appear to be more holes all around. Many of them are too small for the scanner to capture from above. These microdepressions are steep and have sort of tails going in a certain direction. It's possible that the currents underwater played a role in their shape. Everywhere the robot swims, there are new holes all around. After a couple of hours, the robot goes back to the boat with some samples. You take them back to the lab and study them. The robot clearly captures images of human trash, but the samples don't indicate anything alarming for now. Despite the fact that 1/3 of the pockets are filled with trash, there's still no explanation of how they were formed. It's late at night and the rest of your team heads back home. You're passing out in the lab, still trying to find some answers. You wake up the next day, and while cooking breakfast, you get this idea that maybe these holes are gases venting out, which could be harmful to marine life. You quickly get the robot and sail out to the ocean once more. This time, you didn't even think about calling your teammates. You place the robot in the water and get behind the screen to control it. The robot descends to the bottom of the ocean and does a survey. So far, the holes still seem to be covered with trash. But some of the holes have marine life dwelling inside, like fish and seaweed. After much scanning, it doesn't look like they're producing any bubbles, which means there aren't any gases venting out, but you're determined to find them. After a while, you reach one of those large pockmarks, and the robot starts scanning around. You find some bubbles coming from a source, but the robot can't reach it. It swims around trying to find a spot, but nothing. You bring the robot back to the lab and work on it. You attach some mechanical arms on it that can lift things and move them. You bring the robot back down to the same spot, but the bubbles aren't as frequent as before. You use the arms to move some of the trash and find out that the bubbles are being produced by a group of crabs chilling next to a pile of plastic. Bingo! The bad news is, you still don't have a clue why the microdepressions and pockmarks exist. As you try to control the robot to go back to the surface, an octopus wraps its tentacles around it, pulling the robot down. You struggle with the controls and push it to maximum power. but the suctions of the octopus are too strong to break off. It's a game of tug-of-war with the octopus and your robot. It takes the robot under a pile of trash, thinking it's lunch. But you use the arms to maneuver the robot out and swim back to the surface. You go back to the lab even more confused. The robot has collected more samples for you to study. Your eye is glued to your microscope, trying to figure out what's going on, but nothing. You decide to do a carbon dating test to determine how old these holes are. After a while, you check out the results and are even more stunned than before. They show that the holes are around 400,000 years old, so it's likely that human trash wasn't the cause for all this. You pull many all-nighters trying to figure out the truth. You gather your team once more and hold a small press conference about this. You claim that this may be something we should be extremely worried about, but you still can't tell them more than what you know. With all the brain work put together, you find out that the large pockmarks haven't changed or been active for more than 50,000 years. The newer holes were most likely created by human trash settling in the bottom of the ocean floor. The marine life gathered some of this trash like plastics and discarded fishing gear and created homes for themselves. This is why around 4,500 of the holes are newer and have trash in them. But it still doesn't answer why the holes appeared in the first place. You're back to square one. The only way to see what's really going on is to clear up the trash from underwater and study them. The story makes headlines in the local community and catches the attention of a cleanup crew. You organize a trip to the ocean and begin the extraction of all the trash. Many cleanup boats arrive and everyone drops down a net to collect the trash. You send down the robot once more to make sure the nets are hitting the right spot. As most of the trash is being collected, many marine life animals scramble and try to find a way to escape. Everyone makes sure not to hurt them. After a couple of weeks, all the holes are cleared up from the trash. You do another sonar scan from the surface and can see the holes clearer than before. But you still don't have an answer for this. You do some more research trying to see if any other holes appeared around the world. On the other side of the country is a mysterious blue hole off of Florida's Gulf Coast. You catch the nearest flight to Florida and make an appointment with the scientist in charge of the expedition. Blue holes are underwater sinkholes that open below the seabed. Just like on the surface, the underwater world also has sinkholes. This one is called the Green Banana and is 150 feet below. And the hole is 435 feet deep. You dive with some special gear with the rest of the team to a barren ocean floor, and the hole is right there in front of you, looking like an oasis in the desert. You and the rest of the scientists are surprised by the diverse marine life dwelling within. Some sea turtles swim past you, and even sharks. These ones don't harm humans. Halfway through, you reach a narrow path, which makes it difficult for humans to pass through. But everyone is careful. There are corals, sponges, mollusks around the corner. You collect some samples and go back to the lab. Blue holes in general are richer in nutrients than barren lands and host plenty of unique marine life. They're quite common and don't pose any sort of threat to anyone. After making the connections, you don't think the holes off the coast of California have anything to do with blue holes. The mystery goes on.
You step on the surface of the moon. It's unusual. You definitely feel lighter here, and it's easier to walk. You decide to check out that obsessive idea of yours, jump on Earth's natural satellite. And even despite your bulky spacesuit, you literally fly up into the air. Woohoo! Anyway, you continue your walk on the surface of the moon when you feel something strange. The ground under your feet is it shaking? It feels as if an earthquake has just started on the moon, but that's simply impossible. Or is it? Surprisingly, your gut feeling hasn't let you down this time. Moonquakes do exist. In fact, there are 4 types of moonquakes that are strong enough to be detected from a large distance. There are deep moonquakes occurring more than 430 miles below the surface. Then there are meteoroid impacts. Thermoquakes occur when the frigid lunar crust expands. It happens when the morning sun illuminates the satellite after a 2-week-long deep freeze lunar night. And there are also shallow moonquakes. They're the only ones that are similar to earthquakes on our planet. Shallow moonquakes happen 12 to 19 miles below the surface, and they're the most powerful and dangerous. Between 1972 and 1977, the Apollo seismic network recorded 28 such moonquakes, and some of them measured more than 5 on the Richter scale. On Earth, such an earthquake is strong enough to crack plaster and move heavy furniture. Plus, shallow moonquakes are very long-lasting in compared to earthquakes. Once they get going, they can continue for up to 10 minutes. As for the average earthquake, it typically continues for 10 to 30 seconds. Scientists are still not sure what causes shallow moonquakes, and even where exactly they occur. One of the theories is that moonquakes happen at the rims of large, relatively young craters that probably slump from time to time. Interestingly, the Moon and Earth aren't the only places where earthquakes occur. No, scientists have recorded quakes, tremors, vibrations, and shakes in other regions of our solar system too. Let's take Mercury, for example. A few years ago, scientists discovered that this planet was shrinking, and that's why it seems to be so tectonically active. Or Venus. This world is a tectonic puzzle for experts. At the moment, Venus has no tectonic plates, and it might have never had them. But its surface has folds and faults and looks as if it could have tectonic plates. On the other hand, these features might have appeared because of other processes, for example, volcanic activity. But even though we haven't observed any Venus quakes, scientists believe they could detect them since their vibration seems to ripple through the thick atmosphere of the planet. Now, Mars. We know for sure that this planet is seismically active. NASA's lander placed a seismometer on the surface of the red planet, and in 2019, it managed to measure its first Mars quake. After that, the lander continued to record quakes, but they were so weak that if they happened on our planet, they'd be completely covered by the background noise of Earth's oceans. But a space body doesn't have to be a full-fledged planet to have active tectonics. Let's take Pluto. This dwarf planet is geologically active at the moment. In 2014, NASA's New Horizons spacecraft was flying through the Pluto system when it recorded complex geological features on this dwarf planet. Scientists concluded that Pluto might have quakes, or should I call them Pluto quakes, when its liquid water ocean freezes and thaws beneath the dwarf planet's icy crust. Jupiter's moons, Europa and Io, as well as Saturn's moons, Titan and Enceladus, are also geologically active despite their small size. Their features range from volcanoes and water plumes to potential subsurface oceans. Now, I bet you don't know these cool facts about earthquakes that occur on our planet. There's one place on Earth where a whopping 90% of all earthquakes occur. It's called the Ring of Fire, and it stretches around the Pacific Ocean from New Zealand all the way to South America. Looks to me more like a horseshoe. Anyway, experts claim that these countless earthquakes are caused by the abundance of volcanoes in that region and the constant movement of the tectonic plates. Around 500,000 earthquakes happen on Earth every year, but many of them occur very, very deep in the Earth's crust, and only special equipment can detect them. We feel around 20% of earthquakes, and only 100 of them can cause damage. The largest recorded earthquake occurred in Chile in May 1960. It was a magnitude 9.5 on the Richter scale. It was truly devastating. During that earthquake, seismographs detected and recorded seismic waves that traveled all over the world. They shook the planet for many days. As for the most powerful earthquake that occurred in the U.S., it was 9.2 and happened in Alaska. By the way, Alaska, along with California, is the most earthquake-prone state in the U.S. and one of the most seismically active regions in the world. A magnitude 7 earthquake occurs there almost every year. A mega-earthquake can actually shorten the length of a day for the entire planet. NASA claims that really large earthquakes can shift our planet's axis and, thus, change the duration of a day. Now, of course, you won't notice it since this change is measured in microseconds, and 1 microsecond is 1/1,000,000th of a second. Scientists think that the 9.1 Sumatra earthquake, which occurred in 2004, shortened the day by 6.8 microseconds. Now, not even the best specialists can predict an earthquake. That's mostly because the mechanisms that trigger earthquakes are extremely deep underground. But these days, people have learned how to figure out a more precise time frame of when an earthquake might occur. Earthquakes can be triggered by volcanic eruptions or, let's say, meteor impacts, but most of them are caused by the movements of our planet's tectonic plates. Earth's surface consists of 15 to 20 constantly moving tectonic plates. Pressure increases when they shift, and this can make the crust of our planet break. San Francisco is moving toward Los Angeles right at this moment. The speed of its movement is about 2 inches per year. That's as fast as your fingernails grow. It's happening because the two sides of the San Andreas Fault, which is the continental fault extending 750 miles through California, are slipping past each other. So, in several million years, Los Angeles and San Francisco will be neighbors. Lakes, ponds, and canals become slightly warmer and start to stink before an earthquake. It happens because gases get released when tectonic plates shift. Most animals feel these signs and change their behavior. For example, scientists noted toads completely disappearing before an earthquake in Italy in 2009. But as soon as the natural disaster was over, they returned. Even after an earthquake is over, you might still see water sloshing around in your swimming pool. There's no need to worry. This is a phenomenon called a seiche. The water can keep sloshing around for hours after the earthquake is over. For example, the pool at the University of Arizona lost some water from a seiche caused by an earthquake in Mexico that occurred 1,200 miles away. On February 27, 2010, a massive earthquake started in Chile. It measured 8.8 on the Richter scale. As a result, Earth's crust in that region was ripped so dramatically that a city called Concepcion moved 10 feet to the west. Another earthquake resulted in the tallest mountain in the world, Everest, shrinking by 1 inch. It happened in 2015 when a magnitude 7.5 earthquake caused several Himalayan mountains to decrease in size. The Japanese used to believe that earthquakes were caused by namazu, a giant catfish that lives submerged in the mud under the Japanese islands. The fish would thrash about, causing seismic activity. As for the ancient Greeks, they were sure that a powerful sea deity, Poseidon, produced earthquakes by hitting his trident against the earth when he was angry. According to Hindu mythology, 8 elephants hold Earth in place. They are, in turn, balanced on the back of a ginormous turtle, standing on the coils of an even larger snake. And every time any of these animals moves, an earthquake occurs. So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas Fault line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas Fault line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tejon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis. But there's something it can cause more damage than the Big One. The notorious Cascadia subduction zones starts in California and ends up all the way in Vancouver, Canada. The San Andreas Fault line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate, and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas Fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas Fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas Fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put two and two together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed, but Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe. Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us! Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress has accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes caused tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those.